Okay, so a very good morning to all the teachers and students. Welcome to the workshop for NTU Cup 2021 National Secondary School Programming Contest. I'm Teik, and I'm your speaker for this morning. There are 4 sessions altogether in this workshop. I'll be presenting basic ICT from 8:30 a.m. to 9 a.m. As well as in the programming concepts, I'll be presenting basic data types and input-output. Whereas my colleague Lai Siu Cheng will continue with control structures, iteration, and user-defined data types. In session 3, I'll brief on the rules and regulations of the competition, and also to explain to you all on how to use the competition platform, including the installation of the IDE. Whereas my colleague Lai Siu Cheng will demo on the sample questions in C++, as well as a demo on a sample question in Java. Without further ado, let us begin our workshop for this morning. For the first session, I'll start with basic ICT, and then I'll proceed with the programming basic data types, and input-output. As of today, we have 5 generations of computers altogether. The first generation of computing devices are the UNIVAC and ENIAC. The UNIVAC was the first commercial computer delivered to a business client, that is the US Census Bureau, in 1951. UNIVAC and ENIAC used vacuum tubes as the basic components for memory and circuitry for CPU. CPU stands for Central Processing Unit. These tubes, like electric bulbs, produce a lot of heat, and the installations used to fuse frequently. The computers in this generation used machine code as the programming language. So if you do not know what is a machine code, it's basically a programming language that is made up of basically binary numbers, 0 and 1. There's nothing else, but it's only 0, 1, 0, 1 like that. Okay, those binary numbers. In 1959 to 1965, we have the second generation transistor-driven machines. They were the first computer to store instructions into their memory. In this generation, transistors were used. Transistors were cheaper, consume less power, more compact in size, more reliable, and faster than the first generation machines that were made of vacuum tubes. In this generation, assembly language and high-level programming language like Fortran and COBOL were used. So the COBOL programming language, okay, and Fortran programming language are used in this generation, in this second generation. In the third generation computers, from 1995 to 1971, used integrated circuits with chips that were made of silicon. Integrated circuits were first invented by Robert Noyce in 1959. From 1971 to 1980, microprocessors such as Texas Instruments TMS 100, AMD Ryzen 5 2600, and Intel Core were invented and were used in the 4th generation computers.
Oh, no.
From 1980 until today, we have the 5th generation computing devices that are based on artificial intelligence. or more commonly known as AI. Although still under development, there are some voice recognition applications such as Cortana, which is a virtual assistant developed by Microsoft, and Siri, a virtual assistant developed by Apple, that are being used today. So if you want to find out more about Cortana, you can actually try it out in your Windows 10. Click the start button and you can try to start talking. Cortana will be able to assist you. A computer is made up of three main components that are the system unit, the peripheral devices, and the storage devices. In this diagram, it is shown that the peripheral devices consist of the monitor, keyboard, and mouse, whereas the storage devices are the hard disk, USB thumb drive, memory card, tape, 5/4 inch or 3.5 inch floppy disk, CD or DVD disk, and also SSD. The computers that we are using today are no longer equipped with 5/4 or 3.5 inch floppy disk. 各位同学们, when I was still studying in the secondary school that time, the first computer that I bought is actually having a 5/4 inch floppy disk. And then later on, I've upgraded my computer system to have a 3.5 inch floppy disk. But nowadays, we have SSD or hard disk inside our computer. Inside the system unit, there is a motherboard. So this is the motherboard, as you all can see. There are many things inside. You can see here, there are slots. There is a socket here, all right? And there are many electronic components. So inside the system unit, there is a motherboard. The motherboard holds many of the crucial electronic components of a system, such as the central processing unit, or CPU, and memory. And it also provides connectors for other peripherals. The motherboard allows communication between the various electronic components. The CPU interprets and carries out the basic instructions, while the memory holds data and instructions. A sound card, also known as audio card. You can see here, this is the sound card. It's an internal expansion card that provides input and output of audio signals to and from a computer under the control of computer programs. Some sound card may cost a few hundreds of ringgits, such as Sound Blaster AE5 plus Pure Edition. That will cost about 600 to 700 ringgit. It has RGB lighting, Dolby Digital Live, and DTS encoding. Video cards, as you can see here, the video cards, are also known as display adapter, graphics card, video adapter, video board, or video controller, is used to create a picture on display. Without a video card, you will not be able to see this page. Video cards are used by gamers in place of integrated graphics due to their extra processing power and video RAM. This slide shows the different types of memory that is used in a computer and electronic devices. For example, the removable flash memory. So you can see this is the removable flash memory, such as USB flash drive, can be inserted into the USB port of a computer, and the memory card can be inserted into the digital camera. Over here, we have a digital camera, and the memory card is inserted into the digital camera. Here we have the SIM and the DIMM memory modules, and they are inserted into the memory slot of the motherboard. This slide here shows to you the various types of peripheral devices. Basically, they can be divided into three. They can be divided into three categories. The first category is the input devices. The second category is the output devices, and the third one is the input output devices. So input devices are, for example, the keyboard, computer mouse.
No, Logitech G29.
So you can see here there's a keyboard, okay, computer mouse, graphic tablet, touch screen, barcode reader, image scanner, webcam, game controller. So you have a game controller over here. These are the game controllers. Light pen, scanner, and also digital camera. Output devices. So output devices such as computer display, okay, your monitor, printer, projector, speakers. Those are the output devices. As you can see, the name implies input means goes in. Okay, it accepts some data that goes into the computer. Whereas for output devices, it's coming out. So it produces something, okay, to the user or information. But there are also some devices that can act as an input device as well as an output device. Those we call them as input-output devices. For example, modem, and also the network interface card. Every computer system must have at least one operating system installed and running. The operating system manages the software and hardware on the computer, coordinates all the running programs to make sure each program is able to access the computer's central processing unit or CPU. The operating system helps you to communicate with the computer. It is not possible for the user to use any computer or mobile device, such as mobile device will be such as your mobile phone, tablets, without having an operating system. So the graph here and also the table here shows the market share of the various operating systems in the last 12 months. As you can see over here, Android is having the largest market share at 41%, followed by Windows and iOS. The latest operating system from Microsoft is Windows 10 version 21H1. That was released in 19 May 2021. So it's just very recently only. The macOS operating system, known as macOS Big Sur, was released in June 2021 and is the newest version of macOS. There are also various distributions of Linux operating system, such as Debian and Red Hat, whereby Red Hat is a commercial Linux distribution. Ubuntu is forked from Debian, while CentOS is based on the open source code of Red Hat Enterprise Linux, and they are free to download and install. So these are the mobile devices. Mobile devices will need to have mobile operating system installed in them. For example, iOS Mobile is a mobile operating system developed by Apple. Other mobile operating systems are Android operating system that was developed by Google. Windows Mobile, developed by Microsoft, has been discontinued. And BlackBerry operating system, that is a proprietary operating system developed by the Canadian company BlackBerry Limited for its BlackBerry line of smartphone handheld devices. BlackBerry has lost its dominant position in the marketplace to Android and iOS. Computer communication describes a process in which two or more computers or devices transfer data, instructions, and information among each other. To achieve this, a network is required. So as you can see in this diagram here, they are all interconnected. A network is a collection of computers and devices that are connected via communication devices and transmission media. Every device that needs to be connected to the network must have a network interface card, or we call it NIC. The transmission media can be cable, such as unshielded twisted pair or UTP cable, or it can be fiber. So nowadays, I'm sure many of the households, they have a fiber to the home, where they have this Maxis fiber or the DG fiber or Cellcom fiber. Or it can also be wireless. The current mobile network is the 5th generation mobile network that implements the 5G wireless standard. Hubs, switches, and routers are used to interconnect all the devices together. Just like every house have a house address, every device that is connected to the network must also possess an IP address so that they can be sent, so that data can be sent from one device to another device. So IP stands for Internet Protocol. So it's a, or in other words, in layman term, it's a protocol, it's like a language, okay, for the computer to be able to communicate with one another. So they need to have an IP address so that they will be able to send the data from one computer system to another computer system. Recently, there is a growing number of electronic devices that are connected to the internet and have the ability to transfer data over a network without requiring human to human or human to computer interaction. This system of interrelated computing devices, mechanical and digital machines, objects, animals, or people that are provided with unique identifiers is known as Internet of Things, or IoT. In the year 2020, Fullinger mentioned in the network world that there are more than 50 billion IoT devices. And in year 2020, they will generate 4.4 zettabytes of data in that year itself, compared to only 100 billion gigabytes of data that was generated in year 2013. Computers and mobile devices have become a necessity in our life, and they are no longer considered as a desire for us to own those devices. We rely on those devices so much in our daily activities, ranging from doing online e-banking, online shopping, managing our finances, e-learning, and a lot more. There are so much data being kept in those devices and being transmitted from one device to another every single moment of time. Therefore, we must ensure the security of the data that are kept in those devices and the information that is being transmitted from one device to another. Cybersecurity is the practice of defending the computers, servers, mobile devices, electronic systems, networks, and data from malicious attacks. It's also known as information technology security or electronic information security. The term cybersecurity can be applied in a variety of contexts, from business to mobile computing, and can be divided into a few common categories, such as performing an unauthorized access to someone's computer or mobile devices, tapping or sniffing into the communication lines, as well as hacking into corporate server to steal, copy, or alter the data. Cyber threats can consist of cybercrime, cyber attack, cyber terrorism, malware, SQL injection, phishing, man-in-the-middle attack, denial of service attack, romance scams, and a lot more. Cybercrime can be conducted by a single person or groups of people with the aim of gaining financially or to cause disruptions to the system. Cyber attack is often politically motivated with the aim of information gathering, and cyber terrorism is intended to undermine the electronic systems to cause panic or fear. On the other hand, malware can be virus, trojans, spyware, ransomware, adware, botnets that can be spread to computers or electronic devices that will cause damage to the data or program in the storage device. A denial of service attack, also DOS, is a cyber attack in which the perpetrator seeks to make a machine or network resource unavailable to its intended users by temporarily or indefinitely disrupting services of a host connected to the internet. This has financial implications to the companies that encounter the denial of service attack. So depending on the nature of their business, they may lose billions of ringgits a day or could be every second. Finally, here are some advice from me. For wireless devices, do not use the default SSID of a router and make sure that the wireless access point does not broadcast an SSID. I'm sure nowadays, most of us will have a router at home so that we are able to connect to the broadband. So please make sure you go into the admin panel, set it to not to broadcast your SSID. And also make sure that you change the default name of your SSID to something else. Use WPA or WPA2 security standard and configure a WAP so that only certain devices can access it. If you own a website, you can secure the website by authenticating your users and only authorize your users to access to the relevant content in the website. Ensure that the data transmitted by your users is secure by ensuring that the users must browse with HTTPS rather than HTTP. Finally, always make use of strong password. Do not use a password that is too common, such as the number 1, 2, 3, 4, 5, 6. The word password itself, or your date of birth. Those passwords can be easily guessed by hackers who try to break into your computer system. In this slide, I'm going to show you a video. This video will demonstrate to you the hardware parts of a computer via human body analogy. Please let me know if you cannot hear the audio. As a conclusion, we can use our human body as an analogy to the hardware parts of a computer. The keyboards and mouse are like the hands and fingers. We use the hands and fingers for feeding, which is input. On the other hand, the keyboard and mouse are input devices, where they are used for entering data into the computer. The printers are like the legs, because our legs will bring us to places that we want to go to. And the printers are output devices. The speakers are like the mouth and lips, because we use our mouth for talking, output. And the speakers are output devices, because they produce sound. Microphones are like the ears. We use our ears for listening, input. And microphones are used to input audio into the computer. Camera and scanners are like the eyes. The things that we see with our eyes are sent to our brain. On the other hand, camera and scanner are input devices that send images to the computer. CPU is like the brain. The CPU provides instructions to the various computer peripherals, whereas the human brain provides instructions to the various body parts. RAM is like the short-term memory, because RAM is a volatile storage device. Data and information stored in RAM is not permanent and will be erased when the computer is switched off, while hard disk is like the long-term memory, whereby the data and information is permanently stored in the hard disk. We can imagine the computer data bus is like the human body nervous system, whereby the former is for transmitting data and the latter is for transmitting signal. Power cable is like the veins. Veins transmit blood for the body, while power cable supply the electrical power to the computer. Finally, software is like the human's mind, in which both will process the raw input data into useful information. Software is a collection of instructions and data that tell a computer how to work. In computer science and software engineering, computer software is all information processed by computer system, including programs and data. Software is a generic term used to refer to applications, scripts, and programs that run on a device. So here we have some examples of software. Mozilla Firefox, Google Chrome, Adobe Acrobat Reader, Microsoft Word, Facebook, Twitter, Instagram, WeChat or WhatsApp, YouTube, and so on, Google+. So in this slide, we observe that the input devices will supply the raw data to the software program that will then process the raw data into useful information that is then output to the various output devices. So just now that is all for my presentation on the basic ICT. Next, I will continue on with programming basic. So in this slide here, we show to you the basic structure of a C++ and a Java program. On the left-hand side, this is a C++ program. And on the right-hand side of you, this is the example of a Java program. You can see that both of them are very similar, except for a few things. Number one, you can see the first line for a C++ program, you use the hash include to include the library. In this case, it is IO string. As for Java program, you make use of the import keyword to import the Java class. So here we import the java.lang.asterisk, all the classes in this java.lang namespace. And here we are in your C++, we have the using namespace std. Now for a C++ program, you must always start with a main function. The main function will return an integer value, so the return type is int. And therefore, you can see the last line is actually a return with an integer number. Whereas for a Java program, you make use of a class. Inside the class, there is a main function. There is a public static void. So public static keyword, and then followed by the return type. The return type is void, meaning that the main function is not returning anything. So you can see that it's not returning anything. In C++, for output, you make use of the cout, and then for Java program output, you make use of system.out.println. So both of them, C++ and Java program, you are able to write functions. So here we have a max function. Both of them have the max functions created. So in C++, the max functions, the return type is integer. So there is a return to return an integer value. Whereas for the Java program, the function, okay, you apply the keyword public static followed by the return type integer, and therefore the function returns an integer value. So algorithm is a set of step-by-step procedures or a set of rules to follow for completing a specific task or solving a particular problem, especially by a computer. In computer science, an algorithm usually means a small procedure that solves a recurrent problem. It is a well-defined computational procedure that takes some values or set of values as input, produces some value or set of values as output. These are the important criteria of an algorithm. It must be definiteness, meaning that each instruction is clear and unambiguous. Finiteness, the algorithm must eventually stop. You cannot have an algorithm that continues to run infinitely or basically continue to run non-stop. So therefore, we must have it must be finiteness. Effectiveness, the steps are basic enough to be carried out. Runtime speed must be proper. Okay. Actually, I just know how to fry egg. If you ask me to cook, I can only fry egg. And this is the algorithm to fry an egg that I often use. Heat a frying pan for 5 minutes, pour some oil, crack the egg into the pan, wait 4 minutes. If you want a medium yolk, cook for 5 minutes. If you want a harder yolk, cook for 6 minutes. Flip the egg and serve to your users. Here we look at a swap algorithm. So in this example here, we make use of a C++ program. So the function name is called swap. The function is not going to return any value. Therefore, the return type is void. It takes in 2 parameters. The parameter type is integer. And as you can see here, we have n%x, meaning that x is referencing to an integer number. And here we also have a n%y, meaning that y is referencing to another integer number. So x, initially before the swap, x has the value 1, y has the value 2. But temp initially has nothing yet. When you assign the value from the variable x to the variable temp, so temp will now be equal to x, which is equal to 1. In step 2, you assign the value from the variable y to the variable x. So x is equal to y, which is equal to 2. So x will have the value 2. And in step 3, we'll assign the value from the variable temp to the variable y. So y is equal to temp is equal to 1. And therefore, y is equal to 1. And therefore, the final result is that after the swap, x will have the value 2 and y will have the value 1. Pseudocode is an informal, high-level description of the operating principle of a computer program or other algorithm. So it looks very similar to a program. The only difference is that the difference is that, as you can see here, this is not making use of the actual programming syntax. So it's not using C++, it's not in a Java programming syntax, just a normal plain language. So that is a pseudocode. Variables are the names given to a computer memory locations, which are used to store values in the computer program. C++ and Java is a strongly typed programming language because every variable must be declared with a data type. Therefore, the type of the variable needs to be specified explicitly. In computing, data type is a particular kind of data item. As defined by the values it can take, the programming language used, or the operations that can be performed on it. In C++ and Java, data type can be of the following. It can be primitive data types or non-primitive data types. Primitive data type is a built-in data type provided by the programming language as the basic building block, whereas a non-primitive data type, also known as user-defined data type, they are used to hold the data as per the choice of the programmer. So here we have the examples of some basic data types in C++ and Java. So integer, floating point, double floating point, Boolean, character, they are all basic data types. And when you declare them, the keyword will be int, float, double, bool, char. A string is actually a non-primitive data type. There's a difference for the string in C++ as in Java. Basically, the difference is in the character S. C++ has a small character s, whereas for Java, it is a capital S. And here we show you the example on how you can assign the values to the variable. So if it is an integer variable, you assign integer number to that variable. Okay. If it is a double floating point number, then you can assign a double value to the variable. So a Boolean variable can accept the value of either true or false. And for a string, it will have more than one characters. Input and output. Input is information supplied to a computer or program, whereas output is information provided by a computer or program. So in C++, output, we make use of the cout object together with the insertion operator. Okay, insertion operator. So for example, okay, cout, then the insertion operator, hello. The next line we have cout, insertion operator, world. That will give you hello world. It appears in the single line itself. Now, in the second example here, we make use of the endl keyword, endl semicolon, endl keyword. This is a new line. Basically, it means new line. So here, when you have a endl, you will move to the next line. Then it will display the word hello. So the word hello will display in two separate lines. Then for output, you have the print line, and also printf. Basically, the difference between them is that for print line, it will display them in the different lines. And for printf, it provides formatting, string formatting. For example, here in Java, this is a Java sample, system.out.printf, hello %s, exclamation %n. Then the second parameter is the word world. So this word world will go into %s because %s is the string formatting for, it's a string, it's a formatting for string. So the word world will go into %s. So you see hello world, and %n is for new line. Okay, so here we have the converters, D for decimal. Okay, so if you want to display an integer number, you make use of the D converter. Floating point number, you make use of S, and so on. So like just now, you have seen the use of the %n converter. Over here, we have the flags. For example, 08, it means 8 characters in width with a leading 0 because you have a 0 here, so there's a leading 0. Take a look at the example that is shown here. So if you say, okay, so here we declare a variable n. N has the value 461012. And so it is a long integer. And therefore we use %d for integer number. So it will display for us the integer number 461012. Whereas if you use if you have a 08 in front, 08 flag in front, then the width is 8 characters, 8 digits altogether. With a leading 0, okay, in front, and so on. So if you use if there's a percent plus, then you can see it will provide either a positive number, it will give you plus. If it is a negative number, it will give you minus. Input in C++ and also Java. So in C++ input, we use cin. Okay, and for Java, we make use of scanner, the scanner class. So you have to instantiate a scanner object, so and assign to the variable. So the variable myObj is now a scanner object, and you can then make use of the scanner object to receive input from the user. So as you can see the example here, system.out.println will display the output, what is your name, and then using the scanner object, it receive an input from the user. So the user will enter the word John. John will then be assigned to the variable name. And then using system.out.println to display name is John. Input types in Java, the different various methods such as the next boolean, next byte, and so on. So here will be the example of a complete program. So in the very beginning, you must include the libraries that you intend to use in your program, such as IOStream or string. And you also must have the using namespace std for C++. So here we include string library because we are making use of the getLine function. IOStream because we are using the cout, cin. And over here in Java program, we import the java.utar.scanner class because we are going to instantiate a scanner object from the scanner class. And this is your sample output. So I have completed my session for this morning. I've covered with you all on the basic ICT as well as the introduction and to the C++ and Java program and the data types. So now we will proceed with my colleague. Lai Xiu Cheng will now continue with control structures. Thank you very much. Thank you.